All right, so we're going to start on Chapter 8, Section 3, Methods of Proving Triangles Similar. I'm trying to come up with something funny here. I got nothing. Okay, triangle similarity postulate. If there exists a correspondence between the vertices of two triangles such that the three angles of one triangle are congruent to the corresponding angles of the other triangle, then the triangles are similar. We call this AAA similarity. So that's the first part of this. As long as the angles of two triangles are congruent, the two triangles are similar. You don't need to know anything about any side measurements. If there exists a correspondence between the vertices of two triangles, such that two angles of one triangle are congruent to the corresponding angles of the other, then the triangles are similar. We call that angle similarity. This is due to the fact that, due to the no choice or third angle theorem, we can ascertain when two angles of one triangle are congruent to two angles of another, then the third pair of angles are congruent. So we've derived this theorem from that. So this is known as angle similarity. So basically, to sum this up, if two angles of one triangle are congruent to two angles of another triangle, the two triangles are similar. So in our diagram here, if angle A is congruent to angle F, and angle B is congruent to angle G, then triangle ABC is similar to triangle FGH. Okay, so if there exists a correspondence between the vertices of two triangles such that the ratio of the measures of corresponding sides are equal, then the triangles are similar. So if we have an extended proportion of all three sides, then we would use what we call SSS similarity, or side similarity. So again, side similarity theorem. If the corresponding sides of two triangles are proportional, then the triangles are similar. So in our diagram here, if JK to MP equals KL to PQ equals LJ to QM, then triangle JKL is similar to triangle MPQ. All right, so theorem 64, if there exists a correspondence between the vertices of two triangles such that the ratios of the measures of two pairs of corresponding sides are equal and the included angles are congruent, then the triangles are similar. So SAS similarity. All right, so side similarity theorem. If the lengths of two sides of one triangle are proportional to the lengths of two corresponding sides of another triangle, then the included angles are congruent. The triangles are similar. So in our diagram here, if RS to XY equals ST to YZ, and angle S is congruent to angle Y, then triangle RST is similar to triangle XYZ. Now, Oh gosh dang it. So these two angles are congruent, right? Because we would have segment LP perpendicular to segment EA. That would mean that angle LPA and angle NPE are both right angles, and then those two angles are congruent since all right angles are congruent. The next thing I'm going to say is that since n is the midpoint, segment NP is congruent to segment LN. So what I can see here is that segment NP, I'm going to write this out here, segment NP is equal to 1/2 of segment LP, right? So if I were to divide each side here by LP, I would end up with LP here and LP here. Those would cancel. So I would end up with NP over LP is equal to 1/2. Okay. And basically with P and R trisecting, I end up with that there. So EP is congruent to PR is equal to RA. So I know that EP equals 1/2 of AP. So I would do the same thing again over here by dividing each side by AP, and I would end up with EP over AP equals 1/2. So now I can take these two statements here, and I can say that NP over LP is equal to EP over AP. Therefore, we can take the next chain of reasoning, and I can say that since those are proportional, that triangle PEN is similar to triangle PAL. Triangle PEN is similar to triangle PAL, and that is by side angle side similarity. Okay. Here we have another proof. Given that segment KH is the altitude to hypotenuse segment GJ of right triangle GHJ, we want to prove that triangle KHJ is similar to triangle HGJ. So first thing we want to state is the given. Okay, and we have our altitude, and since it's an altitude, we have a right angle. So, and I would say this could probably be the definition. That is the definition of an altitude. Right here. Angle JHG is a right angle. Hypotenuse is opposite the right angle. That's definition of right triangle too. Well, I don't know if that's the definition of a right triangle actually, but that is kind of stating the obvious. The two angles are congruent, right? So angle HKJ is congruent to angle JHG. Right angles are congruent. Angle J is congruent to itself by reflexive. So now we can say triangle KHJ is similar to triangle HGJ by angle similarity. All right. This last problem, the word problem here that we have, and you're going to get quite a few of these. So the sides of one triangle are 8 to 14 to 12, and the sides of another triangle are 8 to 21 to 12. Prove that the two triangles are similar. So in this situation, triangle 1, I'm going to list the sides in order from small to large. So I would have 8, 12, and 14. On triangle 2, I have 12, 18, and 21. So if I can show, and this we'll kind of label this is the small, the mid-size, and the largest side. If I can show that 8 over 12 is equal to 12 over 18 is equal to 14 over 21, which those are all equal because they all reduce down to 2 over 3. Therefore, triangle 1 is similar to triangle 2 by side, side, side similarity.
That's all, folks.
Stay healthy.